Hello. Yeah, that's where. Okay, ready? Okay, welcome. We were waiting a few minutes in case someone else was coming, but apparently it will be just us. You over there, don't you want to come closer? Okay, as you prefer, it's fine. So welcome, this is the RPKI tutorial. I hope that's why you are here, and not just because you don't want to join any other session. The first part of this tutorial is like an overview and the case studies for RPKI. I just want to make a few questions. Who here is not familiar with BGP? Not familiar at all? And with RPKI, have you heard about RPKI before? Do you have any basics about RPKI? Yes? A basics, but okay, so that's why you're here. Makes sense. So, there are some issues, sometime in the routing system in internet, where misdirections or hijacking of prefixes may happen. There are two famous examples, the YouTube incident in 2008 and another incident involving Google in 2012. Apparently by mistake, some operators started announcing prefixes that were not allocated to them, and they made, like, for themselves, it was like a kind of denial of service because they started receiving a lot of traffic that was not supposed to come to them, and YouTube stopped receiving that traffic because what the prefixes they started announcing by mistake were prefixes used by YouTube. And it was something similar with Moratel Indonesia and Google. And so basically, if I can draw something here, if we have a network that has some prefix allocated, let's say a /24 something, it usually receives traffic for that prefix, right? But if we have another AS here that by mistake or for some reason, like trying to make an attack, starts announcing that same /24, all that traffic will start coming here. So for this one, it may be a denial of service attack because they may not be ready to receive that amount of traffic, and that traffic that should be coming here will not get like to the corresponding web server in the case of YouTube, for example. So people trying to access YouTube will get some error and won't be able to access what they were supposed to be accessing. And this happens more often than we think. So those are like two big cases because Google and YouTube were involved. Everyone heard about them and there were news about it and blog posts, everyone talking about it. But sometimes there are incidents like this that happen and no one notices, but they're there. There are some other incidents that happened in our region. In 2014, Indosat leaked over 320,000 routes. That's like 2/3 of the internet, of the prefixes that are usually in the routing tables in the internet. And that disrupted Akamai. And it was, again, similar to what I was saying here, a self-inflicted denial of service attack because they started to get traffic that they were not expecting and they were not prepared to receive. Another case with Telekom Malaysia in 2015, where they tweeted, "Happy Friday," and they thought, week is over, let's go have some fun. And they started announcing a lot of prefixes to level 3 that they were not supposed to announce. So those examples are mistakes. So people trying to do something, trying to set up BGP in some router, and fat finger errors, we call it sometimes. They put the wrong number and everything goes wrong. But this is because of a vulnerability that can also be exploited by attackers. And there are some examples like a hijacking used with cryptocurrency, or a spam house denial of service attack. And there are lots of documents about this, about how to detect these attacks, about how they are made. So it's not something doesn't happen. There are lots of examples out there of hijackings or misorigination of prefixes happening. So how do we address this? BGP was created at a time where there was just a few AESs out there, everyone knew each other, and they could trust each other, basically. If I told my provider, I will start announcing you this prefix, my provider trusted that I was the holder, the legitimate holder of that prefix, and that I had authority over that prefix, so I could announce it. But nowadays, we have thousands and thousands of network operators out there, and we cannot just trust them. So there are lots of checks that should be done. For example, providers, when they start receiving new announcements from their downstreams, they should verify that downstream is the holder of that prefix. And so how do they do that? They should check the legitimacy of the addresses with a letter of authority, for example. And they can also use route objects, for example, in an internet routing registry. But that doesn't have the cryptography part. So again, you're trusting that system, and you don't know if that information was updated with bad intentions, for example. The good thing is that with that databases, you can automate the maintenance of your filters. As an upstream provider, you can base your routing filters on those databases. So, this is what we're here for, right? RPKI, and this is a solution to all those issues that I was mentioning. RPKI is it stands for Resource Public Key Infrastructure. So what it is, it's a public key infrastructure that can be used to secure internet resources, so IP prefixes, right? So it allows us to create a statement saying that a prefix can be originated by a certain autonomous system, and that statement is cryptographically signed so that then it can be validated, so that we can make sure that it was the legitimate holder of the prefix that is saying which origin AES will use to announce that prefix. So it solves those two problems that we were mentioning, route hijacking or misorigination, that are two names, it's like two faces of a coin, right? Because in practice, it's the same. In practice, traffic is going to a different network, to the network it's supposed to go. If it is by mistake, we call it misorigination, because it's someone that, when setting up BGP, made a mistake and entered the wrong AES number or the wrong prefix. If it is an attack, it's like if it has like malicious intention, we call it route hijacking. So how does it work? As I was telling you, RPKI allows us to create these statements that basically answer this question. Is this AES number authorized to announce this IP address range? And that statement is what we call a route origin authorization. A route origin authorization is an object that is digitally signed, that has a list of prefixes with a maximum prefix length so that it allows the aggregation. And it says which is the origin AES for those prefixes. And it is signed using a certificate, and then there's a cryptographical validation of that object that allows us to make sure that it is true what it's established, that is saying. And there's the other side of RPKI. So that first part is generating the information, and then that can be validated, and that will be then used by the routers to decide what to do with BGP messages that they are receiving. So let's say this router implements what we call RPKI origin validation. What it will do is it will get from a cache all this information generated by different people that have like issued those ROAs, and we'll use that information to assign a status, valid or invalid, or there's a third status that is not found, and we will see the detail in a minute, to each BGP message that it receives from the neighbors. So this router receives from its neighbor, a message that was propagated by 2 different routers. One says that this /48 is originated by this autonomous system number, and the same prefix is also being originated by this other autonomous system. So this router receives both messages with different origin AS, and when it goes and checks the information it gets from the RPKI cache, it sees that the origin AS should be this one, so it can say that this BGP message is valid, while as this has a different origin AS, that message is tagged as invalid. So that's basically what RPKI origin validation is. It's assigning a status to all the BGP messages received by a router based on the information the router is getting from the RPKI cache. And so these are the 3 statuses I was mentioning. Valid, when the router finds in that data set it gets from the RPKI cache information for that prefix, and both the origin AS and the prefix length match. So that's a valid announcement. If there is information for the prefix, but the origin AS is wrong, so it's a different origin AS, or the prefix length doesn't match, for example, if someone creates a ROA saying that a certain AS can be deaggregated until a /22, but the router gets an announcement for a /24, the prefix length won't match, so the status will be invalid. And the third status is not found or unknown in the case that there is no information about that prefix, so we cannot say if that is valid or invalid, that BGP announcement. And you may wonder, is this being used? Because maybe you have heard about it in APNIC Apricot meetings, and you've seen tutorials and trainings, but I haven't heard too much about it, like out there, network operators, they're not really doing it that much, especially in our region. So I went found some statistics about the IPv4 space covered. As you can see in our region, there are a few countries that have part of the space they received from APNIC or from their national registry that is covered by ROAS, but not many. And another thing we can check is from that space that is covered, what fraction of space is valid. And at this stage of the deployment of RPKI, having space that is marked as invalid doesn't necessarily mean that there's a hijacking or a misorigination going on. A lot of the cases of invalid prefixes are more related to people being not that familiar with the RPKI system and generating ROAS that don't have the correct information they should have to be coherent with what they are being announcing in BGP. So as the space covered is not that much, being green here doesn't really mean much, because if you don't have any space covered, okay, or just a few of the prefixes, for example, in Australia, the previous slide showed that it's 0, the space allocated to Australia, that is covered by ROAS. Okay, then having valid or invalid space in Australia doesn't mean much. But this is about RPKI, so it's about, about ROAS, so about generating that information that can be cryptographically validated. But then there's the other part that I was telling you about, and it's about origin validation deployment. And it's, okay, once you generated your RPKI information saying which origin AS you will use to originate your prefixes, you also need to set up your routers to start validating using the RPKI information. And I couldn't find any example here in our region about origin validation. And as in a previous life, I was with LACNIC, I knew of some activities LACNIC was doing in the Latin American region. So I wanted to share these are 3 cases from Latin America, but they're very good examples because the 3 of them are were involved in some activities that LACNIC did. They had like workshops and they helped people create ROAS and everything. And after those activities, these two internet exchanges, and this is an academic network, they started, apart from generating the RPKI cryptographic information, they set up their routers to do origin validation. And in particular, I wanted to show the case of Costa Rica, because it's like a good example of how you can deploy this in your network. They started by setting up origin validation in their routers, but just tagging prefixes using BGP communities, so not discarding or not making any decision on the routing based on this, but just tagging, because they wanted to see, okay, how many prefixes are we seeing that are invalid, how many prefixes are not found. And after some time of doing this and working very closely with their members to fix all the issues they had, and to make sure that all the members had generated their RPKI information for the prefixes, after some time in 2015, they started discarding, at the route server, they started discarding invalid prefixes. So currently what they are doing is they discard invalid prefixes, so the members of the Internet Exchange just get announcements of prefixes that are tagged as valid or not found. And they mark not found prefixes with a community so that they can then follow up with the members or with other network operators in the country or in the region to tell them, we are getting prefixes from you that are not found. It means that you haven't created your ROAS. So they are also promoting RPKI to be used. And they do manual checks of invalid prefixes to make sure that, so to check if it's a hijack or a misorigination of a prefix that is being detected, or if it's a ROA that was created with the wrong information. And another thing they do is, for new members, for the Internet Exchange, they have like a quarantine period of time where the traffic is not enabled in the production environment, and they run these tests measuring how many prefixes are invalid, how many prefixes are not found, and they work with this new member to make sure that the ROAS are correct and everything. So that's a nice example that is working, and I think it's a good way of deploying, and I think right now it's a good moment to start working with this, because not many people are doing this, not many people are doing origin validation, discarding invalid prefixes. That means that if you start playing with RPKI right now and running some tests and creating some ROAS, it won't have a real impact on your traffic, but it's a good opportunity because it's still not that deployed, so it's a good opportunity to try something without creating any mess out there. So that's me. That was fast. Well, yeah, I don't know if you want to make questions now instead of at the end. Well, the second part will be a demo and the operations of RPKI, so maybe before going to that part, are there any questions about the basics and generalities of RPKI, deployment, origin validation, all that I told you? Well, the demo is more about the creation of ROAS, right? And the usage of the RPKI system.
Setting up RPKI, sorry. It's about the ways you can set up RPKI and the ways you can create ROAS. Sorry, and also a little bit on router setup.
Question to Sophia, Tashi. I'm not going to say I'm from IPNIC. With regards to what some of the ISPs in Latin America has done, you were saying they're dropping invalid routes. And what are they doing with not found routes? Are they prefing it up and down policies? What sort of policies are they defining?
Not found are being tagged with a BGP community so that they can then follow up with the holders of those prefixes. If there are members of the Internet Exchange, for example, they promote the creation of ROAS, but they may be getting prefixes from other countries or from other networks they don't have a close relationship with. But when they can, they try to promote the creation of ROAS for those prefixes that are not found.
Yeah, tagging is fine, but from a policy point of view, if I find 3/4 of the internet route is not found, example, let's say people have not created their ROAs, what sort of policy am I defining? Fine, tagging it with the community pretty much does nothing. I just tag it, right?
Yeah.
So what am I doing from a policy point of view, from a policy control point of view? Typically, when we did it back in Bhutan, what we did was, for valid ones, we gave it the highest preference. The typical way best practices are suggested, not found, okay preference, default. So I just wanted to know what our colleagues in Latin America were doing. Okay, tagging it is fine, informing folks, telling them to get your ROAs created. It's still good, but
Yeah.
that still does not do much,
Yeah.
the way I see it. So it would be nice to try and understand what's their stance when it comes to preferring a path that is, let's say, not found. How do they do policy control? So that would be a
Okay.
nice thing that
Yeah.
folks would
Yeah, it's something I didn't mention. In the case of the example, they're just tagging with a BGP community and not setting up any routing policy based on that. But it's something I didn't mention. I think it is included in the operations part, but it's good to mention that once you have assigned a status to all the BGP messages you receive, you can then set your routing policies based on that. And as Tashi was saying, for example, prioritizing valid announcements over not found announcements, and of course, discarding invalid announcements. So that would be, but I think maybe it's too soon to do that, because right now, especially in our region, as I showed, the percentage of allocated space that is covered by RPKI is too low. So maybe it's not the right moment to do that. But I think that, yeah, in the long term, the plan would be that your routing policy would be set up so that valid traffic has the highest priority, not found traffic has a lower priority, and then invalid traffic is just discarded. Thank you, Tashi, for your question. Any other questions?
Having RPKI in the network, like security things. So is there any disadvantage of enabling RPKI in the network, in a production network right now? I mean, any disadvantage, like if a BGP flap happens, any kind of route churn, or it takes more time to, validate each route object or something?
I haven't run any tests myself, or haven't read any studies. Maybe Tashi, you have some information. I guess that, yeah, there will be some resources spent on assigning a status to each BGP announcement, but I think that although the deployment is not that advanced, the implementation of these protocols is quite mature, is quite stable, so it shouldn't create any instabilities in any router. So it will consume more resources, but it won't create any instability on the BGP sessions. But maybe Tashi can provide more detail on that.
Thank you.
I actually agree with what Sophia said. Shouldn't have a problem, because the way it works, which Tom will cover, I'm sure will be, your router maintains a copy of the ROAs that are actually pulled by your validator, right? So yes, memory, you need more memory now, because it also maintains a separate table for the ROAs that it pulls from the validator, right? You already have your BGP that are coming in, you have your BGP table that has all the routes that you learn. On top of that, you have your ROA table now sitting, a cache of that sitting in your router. So from a flap point of view, it shouldn't have a problem, because routes come in, I compare it against the cache that I have, and then I tag it based on that. So route flap should have nothing to do with how the validation state is seen, right? But a word of caution, based on my own experience, I did RPKI in 2013. Test it, please, not on a production network. I would request you to do it on a test. Get a BGP feed going there, and then test it for at least 3-4 months, because we went directly to the production network and we broke. And turns out it's not RPKI that broke, it's the implementation in that particular platform that was broken. So Cisco's iOS XE had quite the bug that time, so around 2/3 of the internet routes disappeared. So it was a problem for us. So my request would be not to do it directly on a production. Play with it, observe it, validate it manually yourself,
Yeah.
and then see that, all right, once you're confident, then maybe push it into your production.
Yeah, it's a good practice when you deploy any new technology, right? First try, test it in a test bed, run lots of tests, make sure that everything goes well, and then move it to the production environment. Okay, thank you. Any other questions?
Hi, I just have a few scenario. For example, customer have a /24. They want their prefixes, but they don't have a BGP session. Also, they don't have their own public ASN. So they ask provider to originate the prefixes to upstream provider. So this case, how the RPKI will validate? It's because we are the providers as the prefix announcing ASN number, right? origin ASN number. So, but the prefix is under the another customer. So how they will validating against RPKI?
I think that's covered in Tom's part, right? So maybe we can go through Tom's part, and then if you still have that doubt, we can go with your question again at the end.
Okay. Currently, we are facing the scenarios.
Yeah, no. It's
Thank
a
you.
valid scenario, and I think it will be answered by the next part of the tutorial.
Okay, great. Thanks.
Thank you. Any other question? Okay, thank you.
Okay. So I'll be talking about the deployment and operational side with more of a focus on the deployment side of things, so what address holders do when they want to use RPKI. There are two main approaches to deployment. The first one is APNIC hosted, and the second one is self-hosted. So APNIC hosted is when you set it up entirely within MyAPNIC, and self-hosted is when you run your own RPKI CA software in your network, and it communicates with APNIC backend servers to set up your RPKI links. On the operations side, I'll be talking briefly about router configuration for origin validation, and also about how you can use route maps to use the RPKI state to influence routing in your network. So for deployment, rather APNIC hosted deployment, there are two steps. The first one is actually enabling RPKI in MyAPNIC, and the second one is to use the route management tool to register routes. Some preliminaries before setting up RPKI in MyAPNIC. You need to have two-factor authentication set up. There are two ways that MyAPNIC supports for two-factor. One is client certificates, and the other is one-time passwords. It's probably easier on the whole to use one-time passwords. Browser support for certificates is just getting worse all the time, and we strongly encourage people to use one-time passwords. You also have to make sure that your permissions are set up correctly. If you're a corporate contact for your APNIC account, then you'll already have permission. But if you aren't, you may need to speak to your corporate contact so that they can set you up. Okay, so this is the landing page in MyAPNIC, and if you don't have RPKI set up, you'll get this notification here. And when you click that link, you'll come to the RPKI landing page. So these two radio buttons here map to APNIC hosted and self-hosted. So for this first part, you just leave that as the default and then click next. You get a terms and conditions page after that, which you read in great detail, and then click I accept, and then it will chug away a little bit, and when it's finished, you'll have an activated engine. This part here lists the resources that are in your certificate. In the vast majority of cases, that's the same set of resources that have been delegated to you from APNIC. One exception to that, or really the exceptions to that, are when you are managing historical resources. So after that, to actually register a rower, you go to the route management page. If you're already using the route management page to manage Whois route objects, then there'll be entries in this table at the bottom. But in this test system, that wasn't the case, so it was empty. One thing that will also happen, or may also happen when you're doing this in production, is that there will be options there for importing from Whois and also importing from BGP. So if you have route objects registered for your prefixes and you come here, then it will ask you if you want to register them in this system as well, so that you can manage them for both Whois and RPKI together. So you click Create Route, and you get a page like this that pops up. Prefix and origin AS are self-explanatory, but the next option, most specific announcement, is a generic term we use because this system covers both Whois and RPKI. So RPKI has this concept of max length that Sophia talked about, where you have a prefix for, say, 22, but you want to be able to announce the 24s that are part of that 22. So if you set the max length to 24 for a rower, then those routes will be allowed. This system emulates that same sort of behavior in Whois by creating each of the individual route objects that are required to make that same thing happen. So for example, if you have a route for a 22 and you set most specific announcement to 24, then you'll get 7 objects in Whois. So you get 1 for the 22, 2 for the 23s, and then 4 for the 24s. The next 2 options are about what you want to create for the route, so a rower and a Whois object. You can you can enable or disable on a per route basis. And the other 2 are, well, one is for extra attributes, and one is if you want to email somebody and let them know that this has happened. So after doing that, you click Next. You get this is an example of a filled out form. Click Next. Get a confirmation dialog. One thing that happens though, if you do have max length or you are using max length for the route, is there'll be another table here which shows each individual route. So for example, if you have a 22, max length 24, but you only want the 24s to be permitted, then from this page you can disable the 22 and the 2 23s. After that, generally after waiting a little while so that the backend can actually create the objects, you'll get an entry in this table, and all things being equal, green ticks for the systems that you've opted for, which indicate that everything's okay. All right, that's APNIC hosted. The other approach is to use a self-hosted engine. At a high level, this involves 4 steps. The first one is to actually set up RPKI CA software on your own servers. Typically, that's using the RPKI.net engine, which you can get at that link just there. But of course, the protocols are all standard, so if you had unlimited time, you could always implement your own CA software. After that, you need an rsync server to publish your repository content. Then you need to link your setup to APNIC setup via MyAPNIC. But then after that, all of the rower creation, customer creation, things like that, happen on your side in your network. So the obvious question is, why would anybody go to the trouble of doing this if you can just use MyAPNIC? Self-hosted is mostly useful for members who have, members who have a large number of customers who all want to do, or rather a large number of which who want to do RPKI. You might have, say, hundreds of customers, but if only 5 want to use RPKI, then you might be able to manage that entirely within MyAPNIC. But if you have 500 or 1,000 trying to do this every day, then that's a large administrative burden. And at that point, doing this work and the integration into your customer portal might start to make more sense. In practice at the moment, the members who are interested in setting up self-hosted engines are national internet registries, so our largest members. But having said all that, it can be a useful experience, especially in tests, to go through this process to get more familiar with how RPKI works and to try different things out. For example, if you do set up a self-hosted engine, then you can create a BGPsec router certificate. So if you did want to evaluate BGPsec, then this would be the way to go. If you want to follow along on your laptops through the next part, there's a container that we've put up that will set up an evaluation instance of the RPKI.net software, which you can get by running those commands up there. The docker run command will expose the web interface over port 8443, and it will also expose the rsync interface over port 8873. When you run the container, you'll notice that it does a whole bunch of package installation. That's because the installing of the packages does a lot of per instance work that can't be done during image build time. Once it's finished doing all that, you run the RPKI manage command to create a new user that you can use to log into the web interface and actually create links and things like that. If you are following along, obviously you wouldn't want to use your MyAPNIC account for this, so you can use rpki-testbed.apnic.net instead. And that's a system which will allow you to do all of this stuff in test and get a certificate and all the rest of it without having any effect on how your production is set up. The testbed isn't limited to APNIC members, so anybody can play around with it. But it is limited to 10/8. So even though the trust anchor for the testbed isn't or shouldn't be used by anybody, we limit it to 10/8 just to avoid any doubt about the context. So the first page you get after setting up that rpki.net software is a login page. And once you log in, it will tell you that there are no resource holders in the system. So within an engine, there can be multiple resource holders. If you set this up, then your member account, your APNIC member account, will be the principal resource holder, and you could then manage customers as resource holders also within the system, linked to your resource holder, your member's resource holder. So you create a resource holder. The first field is handle, can be an arbitrary string. The parent is left blank at this stage because there are no other resource holders within the system. And then the users is where you opt for users who can manage that resource holder. Then it's created, and then you click, after it's created, you click Select Identity on the top left-hand side. And you'll get a page where you can pick that newly created member, and then you'll come to the landing page. And this is where you create rowers, manage links upwards, set up repositories, that sort of thing. So one other thing you have to do at this point is click Export Identity. That will give you an XML file which you can take to MyAPNIC to start establishing the link. So once that's done, you come back to MyAPNIC, but instead of picking the first option, you pick the second option for self-hosted engine. More terms and conditions, and then it will prompt you to upload that XML file. And again, there will be an engine activation process, and you'll get a page like this. From here, you click Download Parent XML, which is the response that you take back to your self-hosted engine. And back in your own software, you have this import parent option, which is where this XML goes. You can leave the handle blank to take what's in the XML as the handle. So you upload that, and the link has been established. Now, from that other page, you need to export your XML for your repository, because once the link is established, your resource holder needs to know how it pushes its content out. So once you have that XML, because you're publishing entirely within your engine, you click Repository Clients and then import it using that option, and you end up with a response like this. And again, you have another export, and you take that XML back to your resource holder, where you import it under the repository option. And all things being equal, you click refresh under resources, and you end up with a page like this, with your resource certificate and all the rest of it. So the next step is to create a rower. These inputs are very similar to that from MyEpinic. You have a prefix, max length, and an ASN. So you put all those details in, you click preview, you get a confirmation page, and then you click create. And then there's your rower. Now, having done all that, if you want to see the actual state in the repository, you switch back to the container, you force publication, and then you go to that directory to see your manifest, CRL, and rower. One thing that Apenic is working on to make this, or that will make this a bit easier, is a publication service. So rather than having to set up your own rsync service, you can send the repository content to Apenic via this protocol. And the rpkow.net software has built-in support for that. So that XML exchange from before with the repository instead happens with MyApenic. It's not just about a premium or a slight benefit for an option that's not that used though. We actually have members who are doing self-hosted work who are unable for various reasons to set up a public, globally accessible rsync service. So that's the main motivating factor for doing this work. So that's the deployment on the address holders side. And now we step through the router side. So the first step here is to set up a validator. So there are three different software suites you can use. One is RIPE's validator. Another one is the rpkow.net software mentioned earlier. And there's also one called Ripster, RPSTIR, which can be used too. Of all of these, for the test evaluation, or in the test evaluation context, the RIPE validator is the way to go because it's really easy to set up. You just download it and run one script and it will start and fetch all the content and that's all you have to do. Also, it will have a web interface available on port 8080 and it will make the RPKI router server available on port 8282, and that's the thing that the router connects to. So once that's set up, you switch over to your router. These commands are all for a Cisco router. You switch to BGP, so AS10, just as an example here. You turn off prefix validation, or rather rower prefix validation, so that nothing happens during the setup phase, like it doesn't affect, or routing isn't upset or affected. And then you connect the router to the RPKI router server. So most of that's the third command. Most of that is self-explanatory. The refresh part is about how often the router will go back to the router's, RPKI router server to fetch new routes from it. After that's done, you can verify the connection via the next command, and that will show you all of the route details, or rather rower details, that have been retrieved from the RPKI router server. The next step is to allow the router to use invalid routes, what are invalid according to RPKI, in path selection. So on some models, at least by default, if without this, invalid routes won't be used for path selection, even when there's nothing better available. So that tends not to be, it depends on how you want to set it up, but it may not be the way to go for an initial setup at least. So turning that on is probably a good initial pick. And then after that's done, you can re-enable validation. So the first bit here shows what that table of rower information looks like. And the second is an example of looking at a network once this has been set up. So in this example, that that network is, or rather that route is okay according to RPKI. So there'll be a message about the state being valid. Sophia covered off on this already, but there are 3 states for routes: valid, invalid, and unknown. And probably the simplest or one of the easiest way to start here is to use a route map to have that RPKI state influence routing. So the route map directives here give higher preference to valid routes over unknown routes, and higher preference over unknown routes to invalid routes. But of course there are options like dropping invalid routes that some people use. And I think that is it. Okay. Thanks very much. Does anybody have any questions? Thanks.
Do you still have your question? Do you think it was answered or not? No. Okay, so we said that ROAS can be created by the holder of the prefix, right? If you have a customer, so it's a downstream, that has their own prefix, but they don't have their own autonomous system, so they will be using your autonomous system. What they will do is, as they are the holder of the prefix, they can go to the RPKI system and create the ROA, but they will create the ROA using as OriginAS, your OriginAS. Because what they need is, they need to be the legitimate holder for the prefix, but in the OriginAS field, they can use any OriginAS, whatever they will use in practice, in this case, your OriginAS, okay? So your customer will have access to the RPKI system, and they will create the ROA using your OriginAS, but their prefix, okay? Any other questions? Well, last day of the conference, I guess everyone was to leave, right? Okay, then thank you. I don't think we included our emails, but if you have any questions, you can find us through apnic.net. and the team, you find all of us, or if you want to approach us, we can give you our business cards. And when you start playing with RPKI, you have any doubts, you can contact us. Okay, thank you.